All right, we'll get started with our notes today on 11.1 inverse functions. Should be something that you've seen before in Algebra 2, or if you've taken college algebra or pre-calculus, you would have talking about inverse functions. So a couple definitions I want to mention first before we start some of our problems. Let's just talk about what a function would be. So its math definition would be each x value corresponds to only one y value. Or kind of, we talk about just no x value repeats. All right, so we talk a lot about functions in Algebra 1 and Algebra 2, and then we take it to another step where we talk about one-to-one functions. I believe you've talked about this in pre-calculus and college algebra if you've taken those courses, and then you definitely talk about it if or when you get to calculus. All right, so what this would mean is that each x value corresponds to only one y value. All right, so that looks identical to what I have written above. All right, but there's more. And each y value corresponds to only one x value. All right, so one-to-one must be a function, but it also must have a y value going to only one x. So to be a function, no x values repeat. To be a one-to-one function, no x or y values repeat. All right, and that's the part that will be new for some of you, depending on if you just came out of Algebra 2 or if you've taken a higher level math course than that. All right, we talk about things like the vertical line test. All right, so you would use the vertical line test for a function. All right, so if a vertical line goes through more than one point, then it would not be a function because you have a repeating x value. A one-to-one function would use both the vertical and horizontal line test. All right, because I can't have any x values repeat or y values repeat. So if I draw a horizontal line or a vertical line, it can't pass through more than one point to be a one-to-one function. So we'll look at a few examples and sketches of that. But there's your definitions to start. One more definition, we're going to talk about what an inverse is. So inverse of a function. It's a little wordy in terms of a math definition here, but so if function f is one-to-one, then this means f inverse, so f to the -1 power, if you remember seeing that notation, want to get used to that again. Then f inverse is the set of all ordered pairs or points y comma x, and yes, I purposely put the y in front. I didn't do it by accident. Where x comma y as an ordered pair belongs to F. Okay, so maybe that means nothing to you when you kind of read it in that wordy, math, strange kind of language. But what it's kind of trying to say, so F, just your typical function, uses your regular x, y coordinate points. F inverse, so this one's the inverse. Notice the x and y's switch, your input and output switch for your inverse. It kind of undoes the other function. All right, so kind of x and y switch, or you could say domain and range switch. Or input and output switch. However you are thinking about it. Okay? All right, so we'll look at a couple different ways where we can see the inverses, and if things are one-to-one, we're going to look at just given some points. We're going to look at some graphs. We're going to look at equations. All right, so for this first couple examples, we are going to determine whether each function is, here's the shorthand version for one-to-one, if you want to do that. If it is, find the inverse. All right, so our first example, we're just going to use points. All right, so you'll be given, they usually use a capital letter when they have the point, so they're saying this is function f. It's going to be the set of these points, so then we use little curly brackets to represent the set. You'll see that show up in your Math Excel. We've seen that before. When we talked about solution sets, they leave that there. All right, so my points are going to be -2, 1, -1, 0, 0, 1, and 1, 2. Close my curly brackets. There's my set. That function is represented by 4 points. So I need to determine if this function is one-to-one. Does every x value go with a different y value, or does every y value go with a different x value? Or do any x or y values repeat? Yes, we've got a repeating y value. That would not pass a horizontal line test, so this cannot be one-to-one. So not one-to-one. All right, when it is not one-to-one, you're done. You do not have to find the inverse. We'll do another example. Not very interesting when it's not one-to-one. Maybe you get excited because all you have to do is click the button in Math Excel that says not one-to-one, move on. Okay, so let's do another one. So we'll call this one function g. Little curly bracket action here. All right, 3, 1 will be one of my points. 0, 2, 2, 3, and 4, 0. That's function g. Those are the problem or the points represented in that function. Is this one-to-one? the predictability of my examples probably would be. But yes, it is. There are no repeating x values. I've got 3, 0, 2, and 4. Those are all different. That makes it a function. All right, but more importantly, y, nothing repeats there. That makes it 1-to-1. It would pass the vertical and horizontal line test. This is 1-to-1, so I must write the inverse. All right, so g to the -1 power represents the inverse, so you'll see that notation. It'll have the equal signs. In Math Excel, it's going to fill in those curly brackets. You know, it's going to kind of fill that in, and then you type with inside there. And then make sure you are using parentheses and commas. All right, I've had some students accidentally put like a decimal here by accident in their quiz, and then it marks it wrong, right? Yes, yes, in between the parentheses. Correct. So when I'm finding the inverse, I'm switching x and y or inputs and outputs. So I'm going to write 1, 3. Then I would put another comma to separate my next set of parentheses. Otherwise, it's not going to recognize what it's supposed to be. All right, and then I'll have 2, 0, 3, 2, and 0, 4. That would be my inverse. So not super difficult by any means, just switching those, but we do have to know what it means and what we do. Okay. All right, let's look at an example of a graph. So I know you don't have graph paper in front of you, but we're just going to do a really rough sketch. Okay, so I've got my coordinate plane right here. All right, and if I drew a graph, a V-shaped graph, is this 1-to-1? It is not 1-to-1. Do you know why? It would have repeating y values, right? It wouldn't pass the horizontal line test, all right? Because this y value would be the same y value here and throughout that graph, okay? Would it be a function? Yes, it'd pass your vertical line test. All right, anyone remember what kind of graph this was? What type of function? We're learning about it in Algebra 2 right now. Absolute value graph. You won't have to know that, but it's cool if you remember it. I mean, I think it is. All right, so let's look at another graph. I've got room over here. I'll put another one on the right side. All right, so here, I'm going to put 2 points on here. So we have one at the point 0, 0, and then I have one at 4, 2. All right, so that's as rough as we're going to get for our sketches. That's fine. When it does have an inverse and you have to graph the inverse, you're just going to select the multiple choice graph. Okay. So is this one 1-to-1? It is. Maybe my graph isn't very good. It's just slowly, ever so slowly increasing as it goes up from left to right. So mine doesn't, it almost looks like it's flat, but it's not. So this is 1-to-1. If it is, we need to then graph the inverse. All right, so think back to what we did with the problems above when we had the points. We just switched those x and y values. So I'll go ahead and draw a little sketch underneath this one for your inverse graph. So here's the point 0, 0. We still are going to have the point 0, 0, all right, because we switched those around and it's still the same. But now I'm going to have the point 2, 4. Okay. Now some students have trouble figuring out, well, it makes this curve shape right here. So how do I know which way to curve this? I know those are my 2 points. You can kind of look and see, and you could use some other points that are close to get an idea. Or you always reflect over the line y equals x, which is kind of splits that graph in half diagonally. So if that's easy for you to see, that this would flop that way and reflect over it. Otherwise, use a couple other points, like 1, 1 looks like it's a point about, and then you're at your 2, 4. Let me get rid of that. Okay. So you'll just select, it'll ask you first, is it 1 to 1? Yes or no? And then if it is, it'll move you on to selecting the graph. Okay. All right, so we'll go ahead and look at equations now. All right, so our 5th example, so we look at 2 graphs, 2 sets of points, and then we'll look at a few equations. So I have f of x equals 2x plus 5. Is this 1 to 1? Do you know what type of graph that is? It is a line. All right, would a line be 1 to 1? As long as it is not a horizontal or vertical line, it will always be 1 to 1. So you either need to know that when you look at that that's a line. If you have a graphing calculator, go ahead and graph it and check. You can also use Desmos.com. That's an online graphing calculator if you don't have a graphing calculator. The hope is at this point, when you read this, you know that's a line because you've graphed that in Algebra 1, Algebra 2. We haven't graphed it in Algebra 3, but the hope is that we've seen this enough times. Okay, so it is 1 to 1. So now I'm going to rewrite the inverse equation. All right, so f of x would be my output. X is my input. Depending on what teacher you had for Algebra 2, or depending on if you've done pre-calculus in college algebra, there's kind of different ways you can write inverses. So I'll talk about both so it doesn't confuse you from where you learned it in the past, but there'll be a way that the Math Excel program wants you to write it. All right, so if I think of this as y equals instead of f of x, right, still representing the outputs, this program will say you will switch x and y. So I'd write x equals and y so that I can solve for y to get my inverse. Okay, so I'll subtract 5 from both sides. So basically, for the inverse, you have to undo everything. So 2 is multiplying that now y. I must divide by 2. All right, so my equation would be y equals x minus 5 over 2. Math Excel is going to write your f inverse of x. What is it equal? All right, that's how they'll write it. And then you will fill it in as that fraction, x minus 5 over 2. Okay. In other classes, we've talked about, so the x and y are only switching in terms of if I graphed this, that's my new input. All right. It doesn't necessarily mean that they completely replace each other. So we have some teachers that will disagree with writing it this way. Like in pre-calculus, you probably would have just left it as y minus 5 over 2 equals x. All right, showing that y is your new input, x is your new output. Means a similar thing as what we got here, but you will not enter it in that way. All right, we still subtract 5, we still divide by 2. Okay, but the program will have you write it like this and follow these steps if you ask for help. Okay, so I don't want you thrown off for those of you who've taken some higher math courses and think that we're doing it wrong. All right, there's some debate on this topic on how you're supposed to write it within the math teachers in this building. All right, so as long as you understand what's happening, we're okay. All right, so we'll go ahead and take a look at another example. So f of x equals x squared plus 2. Is this 1-to-1? What kind of graph is this? If you don't know, you can graph it on your calculator, or you can graph it in Desmos.com. Type in your y equals x squared plus 2. See what that graph looks like. Rough sketch makes that U-shaped graph whenever you have an x squared, or 2 is the leading power on your input variable. Would that be 1-to-1? No, it would not pass our horizontal line test. All right, not 1-to-1. Good news, you move on. All right, it does have an inverse, and we kind of graphed it and talked about, like, this would be the inverse of that exists, but the inverse is not a function. All right, so that's one of the reasons we don't dive into actually finding the equation for it, but we just say not 1-to-1, and we move on. All right, last problem for our notes today. Our 7th example here. So f of x equals, in parentheses, x minus 2 quantity cubed. Okay, some of you maybe have graphed something like this. Some of you might not have. This would probably be something to the 3rd power. We don't really look at it in Algebra 2. Maybe in pre-calc or college algebra, but we might not get into our cubic functions much. So this might be one you just want a quick check on a graphing device if you're not sure. You're going to kind of see something like this when you graph it. Maybe I'll change my color. Makes this little curly looking thing. Goes forever vertically in both directions. So this one would be 1-to-1. Okay? So that means we get to find the inverse function. Exciting. All right, so I'm going to change it to y equals instead of f of x. I'm going to replace the x and y just so I solve for y. So I need to undo the cube power here, or the 3rd power. So I must take the cube root of both sides. Make sure you put that little 3, otherwise it means a square root. I'm not taking the square root, I'm taking the cube root. So then I'll have the cube root of x equals, you're left with y minus 2, and then I will add 2 to the other side. So I undo both things that were happening from the original problem. All right, so I'd have y equals the cube root of x. I took the cube root of x first, and then I added 2. So make sure that plus 2 is after that cube root. Okay, so if you're typing in that cube root, which you'll have the option to do that in Math Excel, make sure you arrow over and your plus 2 is not underneath the, I don't know, the roof or whatever you want to call that on your cube root. Okay, but it's going to have it as f to the minus 1 power of x, meaning the inverse of our original function, and then you would type that in. Okay.
So you know what it looks like. You have to like go through all of it and just plug it. You know what I mean? Like if you know when you see x minus 2, the 3rd power, that it's whatever. There's the square root of whatever. It's b over x, and then just add the opposite of what you know that. You go through all this.
I mean, I see what you're saying, because most of them it's just 2 steps to go through it, and you're kind of doing it in your head. Because I mean, I can look at this and go, all right, I'll have to take the cube root, and then I'll have to add 2. So my answer is the cube root, and then add 2. Yes, that's essentially what you're doing. And I know some of you can do that in your head, not a big deal. Moral of the story right now, I'm not collecting your work. You know, and I would have students try to show me a few steps like this on a test when they're physically, turning it in. So I want to see that work, and it doesn't take that long to do. But for the most part, you're probably doing some of that in your head. Just be careful if I gave you a problem like y equals x cubed minus 2, just notice that that is different because I'd have to add 2 first and then do the cube root. So my answer would have x plus 2 all under the cube root because it matters which thing goes first. All right, so if you're getting that and you can skip some of these steps, I won't know. But make sure you're taking your time with it and following your undoing order of operations, basically. All right, so you can use a graphing device to kind of check if things are one-to-one. But really, the only type you are ever going to see in our problems in this unit when it is not one-to-one would be when we have your input variable being squared. So any quadratic equation will not be one-to-one. Pretty much everything else we're going to look at will be. So if you can keep that straight, you'll be good to go. Otherwise, if you got a graphing device or you want to use that Desmos.com, that's a nice free graphing tool online. Just type it in and take a look at it. That'll work too. All right, that's a wrap for our lesson today. Enjoy your faster paced homework.